So there are several types of logic that we have explored. Again, initially it was just a true logic, not logic, and then AND logic, OR logic, NAND logic, NOR logic. Okay, and we completed all these logics, and we already did this first exercise. Okay, and the other two exercises, as requested of one of your friends, going to be your assignment, which is exercise number 2 and exercise number 3. Okay, these two will be your assignment. And the due date for the assignment, if I'm not mistaken, is on the 21st of May. I already said it in your e-learning. And today we're going to look at what is called latching or self-holding. Okay. So there's some situation where you need to hold, okay, a coil energized even when the input which energizes it ceases. Means that, okay, you have an input that trigger the output, but after you release the input, okay, you still want the output to maintain at its stage. Okay, we'll look into some example on this later on. Okay, and latch circuit is also known as self-maintaining circuit. It's also called self-holding circuit. It means certain states will maintain until another input is received. Okay. One of the most common example for this self-holding is a start-stop situation, where you have two switches. Okay, you press your start button once, your system operates, and you release the start button. The system will keep on operating until you press your stop button. Okay, the circuit shown here at the below of the slide, okay, is a sample of self-holding or latching circuit, where you have two inputs. Just imagine the first input is the start button. The second input, IMP2, is your stop button. And then we have a flag or the output. In this example, when we said a flag is an internal variable or internal relay, okay, which can control some output. Okay, I will show you this example. If you want to do together with me, yeah, you are most welcome. Okay, we are going to simulate this in our software, Trilogy software. Okay. Okay, so we're going to do the trilogy. Open the trilogy one more time. Okay, this is the trilogy software, and then we'll build this circuit. Okay, the circuit is shown here, the latching circuit. Basically, we will have, okay, the first input. Okay, we call it as input number 1, or you want it to be a start button, you can put it as start button as the input. And then we're going to add a stop button, which is normally closed, okay, in series, that control the output. Okay, let's put it as a relay output or internal output, internal variable. We call it as flag number 1, probably. Okay, and then we're going to use this flag to hold itself. Okay, so parallel to the start. Okay, we're going to use the flag as another input parallel to the start. Okay, and then the second line, probably we are going to use this flag as well, the same flag, to control the real output. For example, the output here probably just a motor. We're going to start the motor. We're going to start the motor. We press the start button once, the motor will run, and it keep on running until we press the stop button. Okay, so this is one of the application of this self-holding circuit. Okay, so we have the start button, the stop button, okay, controlling the internal variable, internal flag, internal relay, and that particular flag, okay, controls your motor. That particular variable will determine whether the motor will run or not run. If the flag is high, then the motor will run. If the flag is low, then the motor will stop. Okay, let's do the simulation. Okay, if you're going to simulate this, okay, you will see that I'm going to press the start button. Currently, all the output is 0 or off. I'm going to press the start button. You can see when I press the start button, okay, because of the stop is normally closed, so the current can flow from the start, pass through the stop button, because the stop button is normally closed, and trigger the internal relay or trigger flag number 1. Okay. Once the flag number 1 is triggered, okay, all the related, okay, um, all the related normally open contact will also be triggered. Okay, you can see here flag 1 is triggered. Okay, the contact of flag 1 here will be closed. Okay, so it will be high, as well as the contact of flag 1 here will also be high. Because of this flag 1 is high, the motor will stop. Okay, is it clear? Now I'm going to release the start button. Okay, I'm going to release the start button. Okay, you can see here, okay, the flag 1, the input of flag 1 just now, the contact, okay, is holding itself. Okay, it's holding itself here. It keep on holding the output. This is what we call self-holding. Okay, we trigger the output, and the same output is holding itself even after you release the input that trigger the output initially. Okay, that's why if you release the start button, okay, the flag 1 keep on high, and the motor keep on running. Yeah, you press start button again, nothing happened. Okay, release, nothing happened to the flag because it's self-holding. Okay, this line, this active line, which is active from here. Unfortunately, I cannot write anything here. It's not possible to write anything. Okay. Sketch anything. Okay. Basically, when you close the contact, okay, okay, when you trigger the input, okay, initially the current is holding there, and the current is all holding there as well. Because of the contact is normally open, okay, so nothing will trigger the flag 1. But once you close this contact, you press the switch, the start button, so the current will flow pass through input 2, normally closed, and up to flag 1. Okay, and will trigger flag 1. This will be on. As the flag 1 is on, it will switch this contact on and let the current flow over there. And the current will flow pass through the flag 1 and to the ground. Okay. When you cut off this contact, the start, basically you cut off this line of current. But the current is still flowing from here past the contact of flag 1 and pass and go through the output of flag 1. This is what we call self-holding. Even though the current here stops, okay, the current still flowing through the self-holding circuit. That is what happening. Okay? That's what happening now in the simulation. Okay? This is what happening in the simulation. It's self-holding itself. Okay. Until we press the stop button. Okay, when you press the stop button, okay, it will cut off this line. Okay, or basically over here, what happened is that when you press this, you cut off this. Okay, input number 2. Okay, so you will basically cut off there's my eraser. basically it will cut off this current line. I can erase. Okay, somehow my pen does not work. Okay. Okay. So basically, when you I repeat one more time. Okay, initially your current try to flow through input number one as well as flag number one, but it stops because of the contact is normally open. Okay, but once you trigger your start button, you close the contact. The current will flow pass through there and pass through the input number two and to the output. The output will be triggered and the contact that associate with this output will be closed. And the current will flow through here, through the input number two, okay? Through the input number two and through the output. Goes to the ground. Okay? Once you release this input number one, you release the start button. Okay, basically you cut off this line of current. But the current still flowing through flag number one, okay, to the output because of self-holding. Okay. Once you trigger your input number two, the stop button, which is not initially normally closed, and it becomes open, and the current will stop flowing there, which will stop your flag number one. Means that this will be cut off and the current will stop as well over there. Okay, so this is what happening in self-holding or start-stop application. Is it clear? You last start.
Jelas, Doktor.
Okay, I'm going to simulate one more time. Okay, we press the start. We will trigger all the flag and the contents of the flag. Okay, you can see that the flag is now activated. Okay, I press one more time. I press the start button. Okay, the flag will be triggered and the input, the contact of the flag will be also triggered or high, and you will run the motor. If I release the start, okay, because of the self-holding, okay, of the flag one here, okay, self-holding over there, okay, it will maintain the relay as high, okay, or as boolean equals to 1, okay, until you press the stop button, which will stop the flag number 1 and switch off all the contact. The motor will be switched off, okay. So this is what we call self-holding circuit. Okay. Okay, the example here, example for the circuit for this example, I already show it to you just now. Okay, which you have a PLC to control a motor. When the start switch is pressed, motor start. When the stop switch is pressed, the motor stop. Signal lamp to indicate motor is off and on. Okay, means that you can add another line here. Okay, to control the light or indicator. Sorry. You control your light. Okay. So if you start your simulation, you start, okay, it will start the motor and start and switch on the light. Okay, you stop the system, stop the motor and switch off the light. Okay, so you can have multiple output using the contact of flag number one. In other words, your flag number one is your start stop button. Okay, in this example. Okay. So this circuit shown here is the answer for this example for this latching circuit. Okay. Okay. This is the answer. Ada dah, jawapan dah ada. Lupa lah pula. Saya pun tak ingat dah dia. Exercise 4. Build a ladder diagram, okay, to control the system such that the pneumatic cylinder shown below operates continuously when the start button is pressed and stops when the stop button is pressed. Okay. Okay, you want this cylinder to go in and out, okay, and only stop when you press the stop button. Okay, and the system consists of the pneumatic cylinder, and you have these two limit switches, A0 and A1, which will determine the position of your cylinder, whether it is fully extend or fully retract. If the cylinder is fully retract, A0 will trigger. If the cylinder is fully extend, the cylinder A1 will be triggered. Okay? So A0 is to detect whether the cylinder is fully retract. A1 is to detect when the cylinder is fully extend. Then you have this 5-way valve. Okay, remember double acting cylinder controlled by a 5-way valve. And this 5-way valve is controlled by these two solenoid, Y1 and Y2. You trigger Y1, the cylinder will extend. Okay? You trigger Y2, the cylinder will retract. If you trigger Y1, you cannot trigger Y2. If you trigger both, okay, the cylinder will hold at its last position. Okay, so you trigger Y1, not triggering Y2. Okay, and we need to build a circuit to control the cylinder operation. Okay, you press the start button, the cylinder will go in and out, in and out, in and out. When you press the stop button, then only the cylinder will stop. Do you understand what we need to do here? The last start.
Understand, Doctor.
Okay. Can you please try, okay, using your simulation software, solve this problem? I give you 15 minutes or 10 minutes to try to figure out how can you solve this problem. Ini latihan sebenarnya ni. Okay, boleh? 15 minutes? 10 to 15 minutes. Okay. I want you to try, okay, familiarize with this PLC. Familiarize yourself with this PLC. At least you should start with a start-stop, start-stop self-holding circuit. Okay? Okay, so basically the first line is the start-stop. Okay? Start-stop run. And you can put comment if you want. Let's put comment. Very good. Okay, you press start. Basically, you want to extend Y1. Okay. 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 I think this circuit will be appropriate. Let's try to simulate it. Then we have start stop. Okay. Initially, when the cylinder is retract. Okay. Initially, your cylinder is retract. Initially, your cylinder is retract. Means that A0 is active. So in this simulation, I will start with A0 is already active because your cylinder is retract. When you press your start button, okay, you will trigger the flag of the start stop rung, and you will trigger flag 1 over here as well. Okay. Okay. So your flag 1 is on, your A0 is on. Okay. Why our Y1 is not extending? A0, flag 1. Oh, sorry, this is shouldn't be normally closed. Yes. This should be normally open. Okay, initially A0 is already on because of the cylinder is retract. Okay, you press your start button. Okay. Then it will trigger the start stop flag, and then the contact of that flag will be closed. Okay, A0 is already on initially because the cylinder is retract, and it will trigger Y1. When it trigger Y1, basically your valve will move. Okay, the left hand side of your valve will be in action. Okay, will be there. Okay, so your cylinder will start going out. Okay, when your cylinder start going out, okay, when your cylinder start when your cylinder start going out, okay, so it will leave the A0. So A0 will be off. Okay. So Y1 will be de-energized. Okay, your Y1 will be cut off. Okay, your Y1 here, your Y1, okay, your Y1 will be cut off. But since your valve is already at this position, the Y1 position, which is extend, it will maintain at that particular position, because on the right hand side is not a spring type of actuation. If you have spring type of actuation, you disable Y1, it will kick back the valve into its original position. Okay, in this case, you have Y1 and Y2 to control the position of the valve. Okay, although Y1 is de-energized, your valve will still be on the left hand side. Or in other words, your cylinder will keep on extending. Okay, so your cylinder will keep on moving until it reaches fully extend. When it reaches fully extend, then it will touch A1. Okay? It will touch A1. Okay? When it touches A1, A1 will energize your Y2, the retract valve, the retract solenoid. Okay? In other words, it will energize Y2 and this position will take place. Okay? The valve will move from right to left. Okay? When this position is active, then your cylinder is moving, okay? It's moving back, okay? Leaving your A1. Okay? So when your cylinder start retracting, it will leave A1. Okay? Y2 will be de-energized, but the position of Y2, the position of your valve will still be at the same position. Okay, so the cylinder will keep on retract until it reaches A0 when it is fully retract. Okay, lampu pula saya mouse saya. Mouse saya hilang pula mouse ni. Okay, it will retract and it will reaches A0. Okay, when it reaches A0, okay, the Y1 S10 solenoid will be activated. And the cylinder will start extend again, leaving A0. Okay? Although it leave the A0 and disable the Y1 extend solenoid, the cylinder will keep on moving out until it reaches A1, which is fully extend. When it reaches A1, Y2 will be activated and the cylinder start retracting. When it start moving inside, it will leave A1, okay, and move until it reaches A0. Okay, once it reaches A0, extend again, leaving A0, touch A1 again, and then retract again, touch A0, extend again, retract again, extend again, retract again. And it keep on extend, extend, retract until you press your stop button. Okay? Until you press your stop button, then everything will be stopped. Okay? If it is at A0, it will not, okay, it will not activate anymore. Even at A1, if A1, it will retract. It will retract until it reaches A0 and then it won't extend anymore. Okay, the last position it will be is at the retract position. Is it clear or not clear? You want me to repeat one more time? Jelas tak? Boleh tak? Diam
Boleh
ni.
doktor.
Boleh. Right? Just remember a few things, okay, that your valve, okay, your valve, okay, your valve will be at whichever position when it is energized until the other part, the other solenoid is energized. If you energize Y1, okay, your right position will be there. Saya hilang pula. Okay. Okay. If you energize Y1, okay, this part of the valve will be activated and it will keep at that position until you press Y2. Y2 will only switch the valve to its right position. Okay, remember Y1 switch to the left position, Y2 switch back to the right position. Okay, it's not like you have spring return valve, spring actuation on the right, where if you deactivate it, disactivate Y1, it will kick back immediately. Okay, the valve to its initial position. Boleh? Okay, any question? Ada soalan tak? Okay. Saya stop dulu tengok mouse saya ni kenapa hilang. Kenapa mouse saya ni tak ada. Okay, thank you Khalid. Video saya mati. Macam tak ada. Okay, kita nak buat ni tak ada ni. Sekejap saya keluar sekejap, saya masuk balik sekejap Awak kampung kat mana, Selangor
Saya kampung kat Patah Pahat je doktor.
awak orang Bertepahat. Saya
Ha.
ingat orang Selangor.
Saya duduk
Tiga
Selangor.
kali dah ni
Kampung saya
rasanya.
Patah Pahat.
Bertepahat kat mana?
Kat Padikadi. Kampung Padikadi.
Boleh apa gaya ni. Orang Johor ramai sini ni. Awak orang Johor yang balik UTM ni kenapa? Saya pun tanya-tanya jugalah. Yang ada kat sama awak ramai tu Johor ke?
Taklah doktor. Ramai je yang Selangor, Kedah semua ada.
Ada Umar apa khabar Umar? Umar tadi tak datang kelas saya Umar hari Senin. Ha? Oh, awak ada dua nama. Saya ni banyak belajar ilmu dengan awak semua ni. Macam-macam ni. Sejak zaman online ni, macam-macam ilmu keluar ni. Okey, sekejap Saya punya ni masalah si komputer ni. Komputer ni pun dah merajuk Lama sangat saya buat online je. Awak punya subjek maths awak ada maths Sam ni? Tak ada?
Tak ada.
Tak ada Ada school lainnya tak? School lain subjek? Diorang kata nak buat face to face final, betul ke? Saya tak tanya tu sebenarnya. Macam tak logik lah pula kan. Kita tak buat face to face, tiba-tiba sekolah lain nak buat face to face. Kan atas mata-mata tu, kos dia je. Alah ni. sangat dia. Join pun tak nak join meeting kan. Sekejap Saya cuba cari saya punya ni ada kat sini tak. Saya kena guna Mechatronics. Mechatronics. Okay, saya rasa kita terus pergi timers and counters. Ini bahagian akhir sekali. Okay, kebanyakan daripada bahagian akhir ni adalah untuk awak punya general knowledge. Supaya awak dapat sikit ilmu tentang PLC ni, tak aja yang simple-simple, bagilah yang susah sikit. Supaya boleh berfikir lebih sikit. Okay, timers and counters. Okay, so as mentioned before, okay, the boxes in the executive part, you can have the output, or can you have other type of executive function. For example, timer, counter, and other type of function. Okay, this function, okay, included as mentioned here, included assignment, timers, counters, multi-bit operation, arithmetic operation, etc. And there are a lot of function that can be conducted within PLC beside the timer and counter. Okay. So the one showing here is an example of a timer box with the output, connected to the output. This is similar to what been used in Omron PLC, okay, where you have your input followed by the timer, the executive, the function box, okay, and the output. In other type of PLC, normally this will be presented in two rungs, okay. Selalunya dia dua rang. Like this, okay, you probably have your input, your timer, okay, goes to the 0 volt, and then the timer contact will control the output in two rounds, okay. Okay, this is T1, the name of the timer. This is T1 contact in two rounds. Okay, in Omron PLC, somehow they simplify it as a single rung, where the contact of T1 does not exist. It's straight. You can use a contact of T1, but you can straight away connect T1 to the output. Okay. In the simulation that software that we use, is going to be two rounds. Okay, to represent a function. Okay. Okay, there are several type of timers, within PLC. One of them, the most popular one, is on delay timer. Okay, the on delay timer instruction counts time when the enabling input is on. Okay, for the timer requires a signal to initiate the timer. In this example, INP1 is the input signal that controls the behavior of the timer. Okay? As I mentioned before, just now, that in other PLC, you might use two rungs. Okay, this is your INP. Then this is your timer, and you need another rung, which is the timer one that control your output. Okay. It's better for you to remember this because the one shown here is for the Omron PLC. Okay, for the on delay timer, okay, the value is cleared when the enabling input is off. The timer continues sorry. For the delay on timer, okay, basically it takes some delay to respond to the input. Okay, you press your input, okay, then your timer start counting. For example, you set it as for 3 seconds here. You press your input, there will not be any output, or this T1 contact will not be activated. After 3 seconds, then only the timer will provide the output, or the contact will be closed. So it depends on the preset time of your timer. If we set 3 seconds, it will delay for 3 seconds. Let's say you set it for 10 seconds. Okay, you press your input. Okay, it start counting 1 second, 2 second, 3 second, 4 second, 5 second, 8, 7, 6, 7, 8, 9, 10. Then only T1 will be closed and you will get your output. Okay, what happens if you're doing like this? You press your input. You start counting 1, 2, 3, 4, 5, 6, 7. Then you release. The counting of second doesn't reach 10. Once you release the input, okay, the counting will be reset to 0. Okay, you press again 1, 2, 3, 4, 5, 6, 7, 8, 9. You release, okay, it will reset to 0. You press again, you start from 1 again. Okay, this is how the behavior of the timer, on delay timer. If you're looking at the timing diagram, okay, this is the timer status. This is your input. Initially, it's low. You didn't press your input. Then you press your input. Okay? Then it start counting. 1, 2, 3, 4, 5, 6, 7. Okay? At 7 seconds, you depress your input. You release the input. Okay? The timer start counting. Until here, when you release, it will stop. When you press again, it will start back from 0. Starting from 1 over there. Okay? 1, 2, 3, 4, 5. Okay, starts here. It start. Here it will stop. Here it will start again. Okay, and then start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 seconds, then only the timer will produce its output or changes its state from 0 to 1. Okay, from inactive to active, from open to close. Okay, and then it will maintain high as long as your input is high. Your input is high, it will be high. You release your input, the output of your timer will also stop. This is on delay. Okay, it will delay its output until the preset time is reached. Okay, if the preset time is not reached, you release your input, then it will reset to 0. Okay, is it clear? Perlu saya ulang sekali lagi? Tak perlu, saya sedar dulu. Okay, on the other hand, you also have off delay timer. Okay, it takes some time for the timer to produce or to cut off its output. Okay, you press your input. Okay, okay, you press your input. Your T1 will be high, T2 will close. You will get your output. You press your input. Okay, the timer will be switched. The output of the timer will be high or the contact of the timer will close, you will get your input. You release your input, okay, the timer will start counting, right, based on the preset time. And for example, 5 here. After you release 5 seconds, then only T2 will be, the contact will be, okay, will be deactivated or your output will be off. Okay, so it takes some time to switch off the output. Okay, if you look at the timing diagram here, okay, this is your input, this is your timer. Okay, you press your input, your timer go high. It will produce the output. Okay, and you release the input. Okay, you release the input from 1 becomes 0. Here is start counting. 1, 2. Start counting. 1, 2, 3, 4. Not even 5. You press again the input. So it will stop here. Let's stop the time. Okay, and then it maintain high. Then you switch off. They start counting. 1, 2, 3, 4, 5. Then only it will switch off the output. Okay, and as long as the input is low, the output will be low for the timer. You go high, the input, the timer will go high again. You go down, the timer will start counting. 1, 2, 3, 4, 5. Sorry. You go down, the timer will start counting. 1, 2, 3, 4, 5. After 5 seconds, then only goes down. Okay? So it's called off delay timer. Okay? It delay to switch off. And the last one is, okay, accumulative type of timer. This kind of timer is quite the same as the previous one. Okay, on delay. Okay, when your input is high, it takes some time to start the output. Okay, it start counting. Let's say 10 seconds, the preset time. Okay, high, then it start counting. 1, 2, 3, 4, 5, 6. At 6 seconds, you release the input. The timer stop here. It's not stop, it pause. Okay, the on delay just now, it is set to 0. Here it pause. 6, okay? Then you stop, go high, and then it's continue, it's counting. 6, 7, 8, 9, 10, then only it trigger the output. It's quite similar to on delay, but for on delay, when you release the input, it will stop counting. The timer is set to 0. For the accumulative timer, it won't reset to 0. It will continue the last value that it counts. Okay, so they more or less you have 3 types of timer here. Okay, I'll show you an example of a timer before we go for this counter. Start tak boleh ni. Saya begini. Tak boleh out dah pula. Okay, let's do trilogy simulation for the timer. Okay, how to create a timer circuit? Okay, for example, okay, let's have this circuit. Okay, you have input. Let's put it as start stop. Input. Just put an input. Okay. IMP1. And then we have the timer. Okay, timer will be a function here. Okay, you can have timer over in here. Where is timer? Or you can just put your output as timer. Okay, okay. Let's say put it as timer number one. TMR1. Okay. And the preset value, let's put it as 20 seconds. 20 seconds, just 20. This is simulation time, okay? Okay. So if you see here, your timer is timer number one, okay? Set value is 20 seconds, okay? And then we are going to use the contact for timer number one, okay? Contact for timer number one to control our output. Okay, probably the output name is the motor. MOTOR. Okay. So you can see here that this input, okay, the timer is controlled by the input number one. Okay. If you run the simulation, okay, when you press, you see the number of timer number one. Okay. You press the input one. You can see the timer start counting. If you release, the timer stop. Okay. This is delay on. And unfortunately, for this trilogy, you only have delay on timer. Okay, you press, start counting. Okay, it doesn't reach, you release, it will stop counting, and it start again from zero. Okay, countdown. The time is counting down. Okay, 19, 18, 15, and so on. If you press until it reaches the preset time, then only your motor will start. As long as the input is holding the timer, or keep on holding the input, the motor will running. Okay, until you release the input, the motor will switch off. Okay, again, okay, press the input, it reaches 20 seconds, then only the motor will on. And this is delay on. Okay, is it clear? Jelas tak?
Jelas Doktor.
Okay, thank you. Okay, and another one is the counter. Okay, dan keyboard ni pula tak jalan pula ha. Memang hari ni tak nak bagi kita habis cepat ni. Okay. Okay. Another function is the counter. There are two types of counter. One is incremental counter. The other one is a decremental counter. Okay. For the counter, you have the preset value as well. Okay. Okay. The preset value, you set how many count, then only you trigger the output. Okay. For example, you press your input once. Okay. There will not be any output. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it counts the input 10 times, then only you will get the output. If you keep on pressing 10, 11, 12, 13, nothing will happen to the output. Once it reaches the set value 10, the output will be high. Okay, that's why for the counter, you need to reset the counter with another signal here. For example, input number 2. So you need to reset the counter so that it will go back to 0. Okay. If you didn't reset the counter, you keep on giving the input, okay? You keep on counting, the output will keep on, okay, at the high position. Okay, another one is decremental counter. It's quite the same, but it's count down instead of count up, okay? From 5, go down to 5, 4, 3, 2, 1. Okay. There are a few exercises on this timer and as well as counter here. Okay. So I will leave some of the exercises to you, but we will going to do this exercise because I believe if you understand this exercise, you are able to understand the timer and counter. Okay. So this exercise, for this exercise, okay, you need to produce the ladder diagram for an automated system shown below with the following requirement. Okay. A start conveyor motor M1. Okay, this first conveyor is controlled by motor M1. Okay. Start conveyor motor M1. Upon pushing the start button, we press the start button, the conveyor M1 will start. Okay. And when the start, there are metal plates on the conveyor M1. And the metal plate will go to the end of the conveyor and drop down here onto conveyor number 2, which is initially stopped. Okay. And the metal keep on dropping. And each time the motor drops, there is a sensor here. Okay. That counting the number of metal plates. Okay. This is for counting. Okay, the metal plates keep on dropping each time the metal plate, okay, cut off the beam of the sensor will be counting 1, 2, 3, 4, 5 until 15. After 15 plates, okay, M1 should stop. Okay, M1 will stop and M2 will start moving and bring the whole lot of this 15 stack of plates forward. Okay, for 5 seconds. So M2 will move for 5 seconds and then stops. And then repeat the sequence. Means that when the M2 move for 5 seconds, it stops and it will start the M1 again. N1 will still keep on dropping the plates, stacking the plates. After the 15th unit, this will stop, M2 will move again 5 seconds. And then the next stack, the next stack, and the next stack. This will keep on going until you press your stop button. Okay? Can you understand the process? Boleh faham tak proses dia tu? Okay, if you can understand the process, what I want you to do now is to think. Okay, how can you build? I want you to try to build, okay, the PLC ladder diagram program for this system. Okay? Boleh? Boleh cuba? Okay, try for 10 to 15 minutes and then we will discuss. We will discuss. Okay? Boleh tak? If you have any question, just ask. Ada apa soalan, tanya je. 3, 4, 5, up to 15. When it reaches 15, so your counter, when it reaches 15, you're going to start your conveyor 2. Okay, so you're going to start your conveyor number 2. Okay. And remember, when you start your conveyor 2, you need to stop your conveyor 1. Okay. So this counter, basically, the counter that you have here, okay, the counter that you have here should cut off conveyor number 1. So how are you going to the counter cut off conveyor number 1? Any suggestion? Okay. The most straightforward way of cut off this rung, rung number 2, is to add the counter here. But you're going to add a normally close. You add a normally close to conveyor number 1. Let's do some simulation up to here. Okay. We're going to simulate the circuit or the ladder diagram. Okay. Okay, we press the start. Okay. Flag 1 will be triggered. Okay, the contact for flag 1 will close. Okay, conveyor 1 will be on. Okay, flag 1 is triggered. Okay, counter 1 normally close, so the current will pass through here and start your conveyor 1. So your conveyor 1 is starting. Okay, you can see the rest of your program currently is off. When your conveyor 1 is moving, okay, the plate will start dropping. Okay, and the count sensor will start counting. So we're going to do some counting here. Okay, by pressing and releasing count sensor, which is at the input number 3. Okay, I will show you the counting process now. Count. Okay, you can see the counter now. 15, it reduced to 14. Release. Count again. 13. Count again. 12. Count again. 11. 10. We are doing countdown here. 9, 8, 7, 6, 5, 4, 3, 2, 1. And when it reaches 15 count, okay, the counter will be triggered. Again, the contact of the counter will close and initiate conveyor number 2. At the same time, we'll cut off conveyor number 1. Is it clear? Boleh tak? You should be able to see how we manipulate the normally open and normally closed contact for the counter. Okay? The normally open contact is to control the conveyor. When the counter reaches the set value, it will close and conveyor 2 will be started. At the same time, okay, another contact of counter number 1, which is normally closed here, okay, normally closed here at rung number 2, which control conveyor number 1. When the counter reaches 15, okay, instead of closed position, it will be open. So we cut off rung number 2 or rung of conveyor 1. Jelas tak tu? That is how you use the normally closed to cut off any rung that you want. The same as the stop button. You can see the stop button also uses normally close. Means that initially you want current to pass through until that particular contact is released. Okay? Any questions so far? Ada soalan tak? Or anybody cannot run his or hers simulation software? Khalid, okay Khalid?
So far okay there.
Ilmi, okay? Khairul Amirin, okay? Jazio, okay? Apa yang ada lagi ni? Humaidi, okay? Okay, terima kasih. Now start, the rung will, okay? You press start, this rung will initiate the flag, okay, which is the start-stop flag. Okay? And it's self-holding. Even you release the start, the flag is always on. Or in other words, is that when you press the start button and you release it, okay, the system will keep on going, will not stop, although you release the start button. If you press the stop button, okay, the start stop will stop. Then the start stop round will stop. The flag will be deactivated. Basically, the system will stop. Okay, that is the purpose of the first round. Okay, start stop. Okay, we press the start button and initiate the start rung. which is the flag number 1, internal variable. The contact of flag number 1 is self-holding, holding its own rung. At the same time, flag number 1, okay, which control conveyor number 1. In other words, when you start, you press your start button, you want conveyor 1 to start. Definitely, you want the system to start, which is starting by moving conveyor number 1. Okay, flag number 1, okay, controls conveyor number 1. Or in other words, okay, I just remove this initially. Okay, I just remove this. Okay, in other words, okay, I run again. You press start, flag number 1 will activate. Okay, the contact of flag number 1 will start conveyor 1. If you press stop, okay, conveyor 1 will stop. Okay, so that is basically how you start your system. Okay, you press the start button, okay, flag number 1 self-holding, and it will start the conveyor 1. Okay, just remember flag 1 is the start button, it's the same. Okay, start stop. Okay, so basically when conveyor 1 already activated or moving, the plates on the conveyor will start dropping. You need to count, okay, the number of plate that drops from conveyor number 1. Okay, so you are using one sensor, which is the count sensor. Okay, if you remember from the diagram that we have, okay, this sensor is doing the counting. Each time the plates drops, okay, it will cut off this line, or it will trigger a signal to the sensor, okay, and the sensor counting. Okay, so when your okay, when your conveyor 1 moving, the plates start dropping, and you want your counter sensor to start counting. Okay, each time a plate pass through the sensor, the counter sensor will start counting 1. Okay, you can see the counter number here. Initially it's 15, now it becomes 14. Okay, count down. You press again, we reduce 13, 12, 11, 10, 9, 8, 7, 6. Okay, means that your plate is keep on dropping and you're counting. 4, 3, 2, 1. Okay, so I'm going to stop at 1. It needs another drop of plate. Okay, when the plate drops, you can see, okay, the number already reached. The preset number 15 is reached, the counter will be activated. Okay, the counter will be activated means that all the contact of the counter will change state. Okay, so we are using the counter contact here, okay, to control our conveyor number 2. Okay, so when it reaches 15, this contact will be closed and trigger our conveyor number 2. But remember, okay, your conveyor number 1 is still moving. Okay, so you need to know when you should stop your conveyor number 1. It should stop at the same time conveyor number 2 starting to move. That's the reason why we are going to use the counter contact to cut off this line. Okay, to cut off our conveyor 1 line here. Okay, for that reason, I'm going to add a normally closed contact for counter number 1 over there. Normally closed means initially it is closed. Even the counter, okay, even the counter does not reach. Okay, I'm going to run the simulation again. I'm going to run the simulation again. Okay, you can see here when I press start, okay, this contact, because it is normally closed, it let the current to pass through, okay, from flag number 1 to conveyor number 1. Okay, so that's why conveyor number 1 can be activated even the counter doesn't reach its number, because the contact we are using here is normally closed. Okay, and then we start counting 15, and we start counting until we reach the preset number of the counter. When we reach the counter number, okay, the normally closed here will be open. That's why it will cut off the conveyor. The normally open down here will be closed. That will trigger your conveyor number 2. Jelas tu? Kalian boleh faham?
Faham, Dato', faham.
Faham Yang lain-lain okey? Azam okey Azam? Akil okey Akil? Okey, terima kasih Akil So we are able to start our conveyor number 1. We are able to start our conveyor number 2. Okay, so what we should do next? We are going to let the conveyor number 2 run for 5 seconds. Okay, in other words, we need to have a timer. Okay, so we're going to add a timer here. Okay, which input will trigger the timer? This is very important. Or which input should control the timer? When are you going to start the timer? Any suggestion? Ada cadangan?
By using counter 1.
Okay. It looks like it should be counter 1, right? We're going to use counter 1 again to initiate our timer. Awak dah nampak pun. You already get the idea, okay? And then let's call it timer. Timer 1. And let's put it 50 to represent 5 seconds. Berapa second kata? 2 tadi? 5 seconds, okay? I put 50 to represent 5 seconds, okay? If I put 5, it's very, very fast. Okay? The counter 1, we initiate the timer. Okay? Then we do some simulation. We do step by step, okay? To check whether it's correct or not, okay? We start our system, okay? Conveyor 1 running, and then start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15, okay? Until 15, our counter, okay, start, and our timer is counting. You see, after 5 seconds, our timer is on. Okay, I'm going to do it one more time. Okay, I'm going to start again. Okay, what I want you to see is when the counter reaches 15 value, the timer will start operating. Okay, start. Okay, and then counting 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and the counter will trigger conveyor number 2, and you can see the timer here reducing. And when it reaches 5 seconds, it will activate the output. So what are we going to do with the timer? We have managed to trigger the timer. What should we do with the timer?
Put after count sensor.
Sorry?
Put the timer 1 after the count sensor in the circuit number 3.
Okay. Why we need to put it after count sensor?
We put it as normally close, and then when the timer is on,
To
it
cut
will
off the counter.
cut off the counter one.
The counter will not be cut off. Remember, I mentioned to you, okay? The counter, you can cut off by resetting the counter. Okay? So in other words, this timer should reset the counter. That's not one thing you can do. Okay? Let's see here. Okay, we're going to add another rung. Okay? The intention is to reset the counter, right? So we're going to use the timer contact to reset the counter. So reset is this function. Okay, you need to use this function and then reset counter. Okay, you can see here number 2, reset counter. Okay, which counter you want to reset? Counter number 1. Okay, so we're going to reset counter number 1. Okay, let's do the simulation again. Simulate, run all. We're going to start, okay, and our conveyor 1 is now activated, okay, and then the plates start dropping. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, if we go 15, okay, counter will be activated and the timer will start counting for 5 seconds. Okay, 15. Okay, you can see timer start counting, 28, conveyor start, and now you can see your counter, your timer reset the counter. At the same time, we'll cut off conveyor number 2 and start back conveyor number 1. Can you see that? Okay. When the timer reset the counter, it will stop the counter, reset the counter back to 0. Okay. And then conveyor number 2 will stop. Because you reset the counter, the normally close here will be activated again. That allows conveyor number 1 to start back. Okay. So means that your ladder diagram is already completed. Okay, when your conveyor 1 start, then it going to start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then you start your conveyor number 2, stop conveyor number 1 for 5 seconds, and then reset counter, you start back your conveyor number 1. Okay, and then drop again 1, 2, 3, 4, 5, up to 15. Okay, then you start your timer and conveyor number 2. After 5 seconds, your timer reset the counter, stop conveyor number 2, restart conveyor number 1. Okay, so I think you already get the idea. Okay, how I'm going to control an automated system using a PLC. Any question? If you can understand this, it's good enough for you. Ada soalan tak?
Can we make the count sensor automatically?
Can we make what?
A count sensor operate automatically.
You mean the count sensor?
Ah.
No, definitely not. Okay.
We need to do it manually.
You need to trigger, to simulate it as what happening in the real world. Okay. You need to trigger the count sensor manually. It's like you are counting the metal part that's dropping. Okay. Ada soalan tak? Any question? Okay. Okay. Your test on this PLC is up to the assignment. And there won't be any question on timer and counter. I don't think so. It will be very time consumed for you to think how to create the ladder